Welcome back, students. We will be looking at section 1.7, terminology for property of real numbers. There's nothing to actually write out on these notes, but I wanted to go through and explain what each of these properties mean, so that when you are asked the questions to determine which property is being used, you can actually tell which one's being used. So the first one that we're going to look at is commutative property of addition. You'll notice that it just says commute to different locations. So what that means is the items, whether it's variables or numbers, they're going to change order right here. And you'll notice that we have A plus B, and then we have equals B plus A. So what we're comparing is what is different from the left side when we look at the right side. How has the left side changed to what is actually in the right side? So the original problem would have been A plus B, but then the change that was made was B plus A. So they actually switched order. Now let's look at the examples that I have. We have 10 plus 8 equals 8 plus 10. All that happened was they switched order. The value of the problem didn't change. It's still going to result in 18 on both of those sides. All it did was change what number was listed first and what number was listed second. Looking at the second example, we have 2 plus, and then in parentheses 1 plus 3 equals 2 plus, in parentheses 3 plus 1. Now notice the 2 plus did not move. It's still the first thing listed. So for this to be considered commutative property of addition, something had to change order. Well, what changed order was the 1 plus 3 and the 3 plus 1. So they switched locations. The 1 commuted to the second location and the 3 commuted to the first location. They switched parking places, let's say. All right, so what is the difference between commutative property of addition and the commutative property of multiplication? Well, addition and multiplication, pretty simple, right? So it's the same rule. They're just switching order, changing order, but in the property of multiplication, it's dealing with multiplication here. So AB equals BA. They just moved parking places again. Looking at our examples, we have -3 times 5, and then it switched to 5 times -3. Again, it's not changing the value of the problem. We're just switching locations of the numbers, the order of the numbers. It still would be -15 equals -15 if we were to solve it. Well, now let's look at the second example that I give you. 1 times 9 times 2 equals 9 times 1 times 2. Okay, something switched order. The 9 and the 1 switched order, so that is why it is commutative property of multiplication. Now, where students often get confused or they struggle to remember the difference is between the commutative properties and the associative properties. So let's go over the associative property of addition. And what that means is we're going to change associates, who we are grouped with. We're going to change our friends. We're going to change our roommate, so to speak. So when we look at our rule here, A plus B is in parentheses, and then plus C is outside. So how did that left side change to what we see on the right side? Well, what changed is A is no longer roommates with B. B is now roommates with C, and A has a room all to itself. So we changed who was grouped with who. Now let's look at an actual math example of this. 2 plus 1 plus 3, and then 2 plus 1 plus 3. We didn't change the order. What changed was who was rooming with who. So originally the 1 was sharing a dorm room with 3. But then they got into an argument. I don't know. They just couldn't get along. So now 1 is sharing a dorm room with 2, and 3 has their own room. So again, it's just changing who is associating with who is grouping with who. Looking at the second example, we have decimals. It doesn't change the rule. It's still being who is with who, and if that changes. So 0.5 plus 4 is together on the left side. But then when we move to the right side, 4 is now with 0.2. So it changed who was grouped with who in that parentheses. When we look at the associative property of multiplication, same thing. It's talking about who is grouped with who and how that changes, except we're dealing with multiplication. So in our rule, we have A and B together multiplied, and then we have C multiplying against those on the outside. When we look at the right side, we now have B with C, and A is by itself, but it's multiplication. Looking at our numerical examples, we have 5 outside, and then B times C is inside parentheses. They're roommates. But when we go to the right side, 5 is now roommates with B, and C is alone. Again, let's look at our next example. We have -6 times 8 within the brackets. That means they're grouped together. But when we go to the right side, -6 is no longer with 8. It is now grouping 8 and 3 together. So they have switched roommates. They are no longer sharing the dorm room. Now let's look at the identity property of addition. What that means is the original value doesn't change. So if we start here with our rule, A plus 0 equals A. What that is showing is that you can add 0 to anything, any number or variable, and it will stay its original value. So what it means is stay yourself. Just keep that in your mind. So for example, 17 plus 0 is 17. It didn't change the value of the original number of 17. It stayed itself. It stayed its own identity. Well, what if we have -17 plus 0? It's still going to stay -17. 0 does not change its value. So that's why it's called the identity property of addition. Well, what about the identity property of multiplication? Again, the original value doesn't change, except instead of using 0 this time, we're going to use 1. Because if we use 0, if we say A times 0, we're actually going to end up with 0. Because remember, anything multiplied times 0 is 0. So we can't use that for our identity, for the identity property of multiplication, I should say. So let me erase that. So that's why we're going to use 1. Anything times 1 stays itself. So A times 1 is A. So A has kept its identity. Now let's look at the example. We have 1.2 times 1, and that stayed 1.2. We have -1.2 times 1, and that stayed -1.2. So just remember, the difference in the two identity properties is when you're using the identity property of addition, you're going to add 0. When you're using the identity property of multiplication, you're going to multiply by 1 to keep those terms the same. All right, well now what about the inverse property of addition? Basically, inverse means opposite. Okay, so we're going to cancel the original value with its opposite value. So looking at our rule here, A plus -A is 0. Basically, those A's are canceling themselves out. So looking at an example, 4 plus -4. Well, when we think about our positive negative rules in addition, we know that if they're different signs, we're going to take the difference and keep the sign of the larger number. When we take the difference, we end up with 0. And so that's our answer. Well, what if we have the -4 first and +4 second? We still take the difference because it's two different signs, and we end up with 0. So basically, a positive plus a negative of the same value will cancel itself out and give us 0. This will be very important later when we start solving equations with variables to find the value of those variables. That's why the inverse property of addition is so important. All right, so the inverse property of multiplication is another important one. So we're going to cancel the original value with its reciprocal value. That's important. Reciprocal. Remember, reciprocal just means the flipped version of the original number. So looking at the rule here, we start out with A. And we can put a over 1 to make it a value, a fraction. Remember, anything over 1 is itself, so we can do that. But then we multiplied it by its reciprocal, 1 over a, okay? The reason we do that is because we end up with a times 1, which is a, and then 1 times a, which is a. Well, a divided by a is 1. You have 1a in 1a, basically. Sounds kind of weird, but that's what we're saying. Erase that out of the way. All right. So whenever you want to cancel a value dealing with addition, you're going to use its opposite value. If it's positive, you're going to use the negative. If it's negative, you're going to use the positive. When you're doing cancellation with the property of multiplication, remember you're going to use its reciprocal value, its flipped version. Multiply it, and that will cancel it out. So let's look at an example over here. We have 3 over 7 times 7 over 3. So 3 over 7 is our original fraction. And then if we multiply it by its reciprocal, which is the flipped version of it, the 7 over 3, we are going to end up with 21 over 21. Well, that would reduce to 1. And that's why we do it. So when we get to solving equations, finding the value of variables, this rule allows us to perform a certain step that we need to do to get x by itself or whatever variable we're solving for. So that's why this is important. So just keep in mind that when you need to cancel something, you would multiply it, cancel it with multiplication, you would multiply it by its reciprocal so that you can get 1. Let's look at the second one. We have a negative 3/7. We're going to multiply it by its reciprocal, which is negative 7/3. We're going to end up again with 21 over 21, which is 1. And that's why this, the inverse property of addition and the inverse property of multiplication is so important. All right, distributive property. This is our last one. This is one that you will use a lot. So it's really important to memorize this one. So the distributive property, I'll go to green here. You're going to multiply outside values with all the values in that parentheses. So our rule here, you started out with what's on the left-hand side. So what they mean by multiply what's outside with everything that's inside is this. We would say a times b, which gives us AB. Then we would multiply a times c, which would give us AC. And we have that plus sign in between. So let's look at an example. We're going to multiply the negative 6 times the c to get negative 6c. Then we're going to multiply the negative 6 times g to get that negative 6g. Keep that plus sign in the middle. All right, now let's look at this example, because you might see a problem like this, and it's probably going to ask you what property is being used. And you'll say, well, I don't know, because it's going from 20 plus 5w to equals 5 times 4 plus w. Well, all it is the distributive property backwards. They're factoring. So what they did was they pulled 5 out of that 20, which 5 times 4 gives us 20. So that leaves 4 in here. And then they pulled 5 out of the 5w, which left us with w, which is what we have right here, 5 times 4 plus w. So if you see a problem like this, just recognize that they're factoring, which is just the backward steps of the distributive property. All right, guys, that's the end of this particular terminology video. So let's look at our quote. Mathematics reveals its secrets only to those who approach it with pure love for its own beauty. Archimedes. All right, hope you guys are having a great day. I'll see you in the next video. Bye.